Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of implicit differentiation. And here, let us recall what you have seen previously. All the functions that you have dealt before are all explicit. So when we talk about explicit, it means that you are able to express one variable clearly in terms of another variable. For example, here we can see that y depends on x, and so the equation given here is clearly expressed in such a way that y is the only variable on the left side of the equation, and then on the right side of the equation we have everything that is related to x. And the same thing for this one. Here we are able to express y, so y is the dependent variable, and here x is in the independent variable, so x is on this side and y is on the other side here. So that is the idea of explicit function. Now, in some circumstances, you will see examples of implicit functions, and you might be asked to get the derivative of this type of function here. So what is the meaning of implicit function? Implicit means something where it is not stated clearly. You are unable to obtain the function as clearly as what you have seen in this example here. To give you an example, consider this function. You have x cubed plus y cubed is equal to 6xy. Can you try and rearrange the equation here so that you have y on the left side? So y is a subject. Can you rearrange this equation so that y is on the left side and all the x is on the right side of the equation? Well, we can try and do that now. So let's say, so we have this one. This can be written as y cubed is equal to 6xy minus x cubed. So we still have y on this side. How are we going to get rid of this value of y here? There's nothing that we can do. It is impossible to rearrange this equation so that we only have y on the left side and x on the right side of the equation. So when we are faced with this kind of scenario, there is a simple method of which you can obtain the derivative of implicit function. And the method here is very simple. What you need to do is you need to differentiate both sides of the equation with respect to independent variable x. So if x is your independent variable, then you are going to differentiate both sides of equation with respect to that independent variable. And once you have done that, you are going to solve the equation to find the value of the derivative dy dx or f prime x. Okay, and I think the whole process here will become very much clear if we look at one or two examples. Yeah, so that's what we're going to do next. Here we have an equation of a circle which is given as x squared plus y squared is equal to 25, and you are asked to find the derivative of this function here dy dx, which means that y is considered to be your dependent variable and x is your independent variable. Okay, so now after you have managed to get the derivative of it, you're going to use the answer to get the equation of the tangent line to the circle at this specific point. So if I want to represent the whole example here using a visual representation, this is how it's going to look like. So this is the circle, and notice that 25 here can also be expressed as 5 squared, and this is a classic equation of a circle where you have a general form of it is going to be x squared plus y squared is equal to r squared. So r here is the radius, which means in this case the radius is 5, radius of a circle. This is r is equal to 5. You can see it clearly here. This is the radius, which is 5 units. Yeah. So we are going to start off with finding the derivative of this dy dx, and the first step is to differentiate both sides of the equation with respect to x. So I'm just going to write down differentiate both sides of the equation with respect to x. It's going to look like this. So this is on the left side of the equation, and here differentiate with respect to x on the right side of the equation. And we know that these terms here can be separated, so we can consider them separately. Plus y squared. And if you differentiate a constant here, the answer is going to be equal to 0. So on this part, if you differentiate x squared with respect to x, the answer is going to be 2x. And here is going to be a bit tricky, and I'm going to explain this part here on how you can differentiate y squared. Okay, so we are going to use the idea of chain rule, where you have this part here can be considered as outer function. So if you differentiate that, you will get equal to 2y, and it will be multiplied with the result of finding the derivative of the inner function. So this is the inner function. So if you differentiate y with respect to x, the answer is going to be equal to dy dx. Okay, and I'm going to explain to you why the answer is going to be equal to dy dx. Recall that previously, if you have an explicit function, which is y equals, I just give you a simple example. Let's assume you have an explicit function which is equal to 3x squared plus 6. So if I ask you what is the derivative of this function, what is the derivative of this function, you can say that derivative is going to be dy dx, and since y is explicitly written in this manner, you can actually substitute this with 3x squared plus 6, and you can go on and differentiate this function here, and the result that you will get is equal to 6x, right? So that is very simple example. Now let's assume that you have a function y is equal to something that you don't know. You don't know for sure what is y. So what is the derivative of this function? So what is the derivative of this function? And using the same manner, you can say that the derivative of this function is going to be equal to dy dx. And is there any else that you can do? Well, there's nothing else that you can do, because you really don't know what is dy dx. You cannot solve this whole thing yet, so you can just leave it as that at that point. Yeah, so this is what's going on here. We don't know what y is for sure, so we can just say the derivative of this function is just going to be equal to dy dx, and stop at that point for the moment. Okay, so now we're just going to continue. This is equal to 0. And next, in order to find what is dy dx, we're going to solve this equation and get what's the value of dy dx. So here we can say that therefore 2y dy dx is equal to negative 2x, and then dy dx, therefore dy dx is equal to negative 2x over 2y, and this can be further simplified as negative x over y. Okay, right, so now we have managed to solve the first part of this example. Now we are going to use this answer here, and we are going to obtain the equation of the tangent line to the circle at point 3, 4. And the visual representation of this is going to look like this. So here we have a specific point at 3 and 4, and this is the point here, and we have a tangent that passes through this specific point 3 and 4. Yeah, so we need to find what is the equation of this tangent line. So first of all, we need to find, of course, what is the slope of this, and the slope of this is given by negative x over y. Okay, so let's continue with this example here. Just going to erase this part. Okay, so now the slope of the line is going to be equal to, the slope is equal to dy dx. And what is dy dx? It is negative x over y. So what is the value of x and y? The value is 3 and 4. So we're just going to replace that with negative 3 over 4. So that is the slope. And we know that in order to find the equation of this line, we just need a slope and a point. So here is a point, 3 for x, 4 for y. So we can create the equation, which is y minus y1 is equal to mx minus x1. Y minus the point of y1 is 4. The slope is negative 3 over 4. X minus 3. And then you can simplify the whole look here. So you will get y is equal to negative 3 over 4x plus 9 over 4 plus 4. And this is equal to negative 3 over 4x. So here is going to be 16 over 4. 16 plus 9 is going to be 25 over 4. So that is the equation of the tangent line to the circle at this particular point. Okay, that's all for now. Thank you very much for watching.